Hi everyone, you're welcome to Easy Science channel, ILED Excel Physics, WPH1101, January 2021, Part 1 of the Unit 1. Shall we start with the first question? Question number 1. A car is moving towards a stop sign at a speed of 25 meters per second. The driver applies brakes 20 meters before the sign and decelerates uniformly to rest just before the sign. Which of the following gives the magnitude of the car's deceleration in meter per second square? So, the first thing you must do is, when you are reading the question, you have to underline what the important points. Actually here 25 meters per second I have already underlined. So then you are saving the time in one hand, and the other way you know the units. With the units you have to underline the important words as well. Now see, you will see it is to rest. That means you know final velocity is going to be 0. Now it is 25 meters per second. What is that? That is the initial velocity. So you write, can you see I have written already, u is 25. All the data, what you get from there, you write. U is 25, S is 20 meters, V is 0, A is acceleration we want to find. So T is X. Here I want to tell you one thing. All the motion equations, kinematic equations I have given, those equations are vector equation. So you know what is vector. Magnitude and the direction is there. Scalar only the magnitude. So direction you have to specify when you are using these equations. Okay, and here I haven't written the units. I'll advise all of you to write the data with the units. Then you will see if it is not SI. If you see it is not in SI, immediately then and there you transfer into correct SI unit. Then you are not doing any mistake when doing calculations. So that is another point I am giving you. Now see, these equations you should know. Distance quantity not used is distance in V equals U plus AT. That means if you want to find distance, you have to use this. Likewise, acceleration, you have to use this. Final velocity, here final velocity is not there. So if final velocity is not given, you have to use this. If distance is not given, you have to use this. If time is not given, you have to use this, because time is not there in this equation. So you know what to use. Now see, we'll go back to the question. Which of the following gives the magnitude of the car's deceleration? You know what you get from here is acceleration. Remember, if you get a minus figure to this acceleration, that means it is deceleration. There's another word for deceleration, that is retardation. If you get the word retardation or deceleration, the sign is there. So if you sign is inside of this word, think like that. It is hidden in these words. What are the words? Deceleration and retardation. So when you use this kinematic equation, you are getting acceleration. So your acceleration should be minus, because we know it is a deceleration. When acceleration is minus, if you are using the word deceleration, please remember to omit minus and give you the answer. So when you use this, you know it is initial velocity is 25, it is minus, and this direction we are using this forward direction. So you have to mention the direction. So this is the correct calculation. If this comes in the second paper, also the same way. That's why I am giving you all the workings here for you to understand better and to give you a knowledge for your second paper. Okay, question 1 is done, so we will move on to question number 2. Question number 2. An object of mass 8.2 kg initially at rest falls a vertical distance of 25 meters through the air and has a final velocity of 20 meters per second. Which of the following gives the energy in joules dissipated by air resistance? What is dissipated? You just think it is transferred by air resistance. Now you have to remember, this kind of situation we always know it is gravitational potential energy and kinetic energy. We are dealing with GPE and KE. We all know when GP increases, kinetic energy decreases. So that is GP is eventually getting transferred to kinetic energy, in other words. So it is a fall, vertical distance. But here by air resistance. Now air resistance is going to be there. When you talk about free fall, there's no air resistance. It is falling under gravity. But here they have mentioned air resistance, by air resistance. So you have to get the difference. GPE, what is GP? Transferred. Transferred means GPE minus KE. So what is GPE? mgh. What is m? 8.2 kilogram. G is 9.81 into 25. You have to minus K because they are asking dissipated. Why it is dissipated? Because of the air resistance. Okay, if there is no air resistance in free fall, so you are just telling your gravitational potential energy is transferred into kinetic energy. But here air resistance is acting, so you have to get the difference to see dissipated, energy dissipated. So that's why you are subtracting kinetic energy. Kinetic energy is half is 0.5, half m is the same m, 8.2, v squared is 20 squared. So this is the answer. For question 2, C is the answer. I hope question 2 is clear for you. And shall we move on to question number 3? In every question, I have given you full detail for you to go through, and all what I need to tell you is there written. So no problem for you. I hope you are clear with all my answers. So question 2, I have given you further. Let me see question 2 again. So I have given you the diagram for you to understand very well. So I hope you understand. And shall we move back again to question number 3? So you are getting the graph. So always you have to accept a graph. Okay, the graph shows how the acceleration a of an object varies with time. So first of all, I must tell you one thing. When you get a graph, you have to read x-axis and y-axis before doing anything. you have to understand what the graph is. This is graph of acceleration and time. You all know velocity time graph. You all know distance time graph. So this is some of A and T. So you have to be very careful of transferring A and T to V and T. They are asking velocity time. So you have to transfer acceleration time graph to velocity time graph. Now see, question is asking, the graph shows how the acceleration A of an object varies with time. They have given the graph. Which of the following graph shows how the velocity V of the object varies with t? Now see, in the graph given is acceleration. But you know that acceleration is positive. How do you know acceleration is positive? The graph giving you a positive gradient. Positive gradient is, that means with x-axis, the graph is getting an acute angle. So that is, this is a positive gradient. So in the graph, acceleration is positive. The acceleration is given by the, when you transfer acceleration to Vt graphs, so acceleration is the gradient of Vt graph. When you go to A, the gradient is negative. So you cannot take A. Okay, it's wrong. When you go to B, it is acceleration increases. In B, acceleration decreases. Okay, now see here, the graph given, acceleration is increasing. That is positive gradient. But in Vt graph in B, you see acceleration now is the gradient. Here, I'll tell you again, AT graph, when time goes, A increases. Can you see? A increases. When come to Vt graph in B, acceleration is the gradient. So now here gradient is decreasing. Finally, it is almost zero, parallel to t-axis. So B is wrong. We want the graph, Vt graph with increase in acceleration. So now see, answer C, in this graph, acceleration increases, okay, but it is constant. So if acceleration constant, this graph should be straight line. So C also wrong. Although acceleration in gradient increases, it is constant acceleration. But here acceleration is varying. So C also wrong. So answer is T, corresponding to Vt would increase its gradient. It's T. Okay, I hope you understand. So you go to move on to question number 4. A student measures the time t taken for a ball bearing to fall different measured distances s from rest. Now underline from rest. I told you. The student uses his measurements to plot a graph with a gradient equal to the acceleration due to gravity g. Which row of the table shows a graph with a gradient equal to g? Now, we have to know y-axis, x-axis. Means they are talking about a graph. So, you should know the formula first. First, go to the formula. What is gradient? What do you know? It is, you know, gradient is delta y over delta x. That is g. Okay. So, you know g. So, what is the formula? You can find gradient. Here, S equals ut plus half at square, because from rest u is going to be 0. Time taken for ball bearing different distances, so you should have distances, so you have to use this equation. I told you at the beginning, the student use plot a graph gradient, and you know when you have this experiment. Okay, it is there in your syllabus. So now, to find the gradient d, so you use this, and s equals half gt, since u is going to be 0. Then what is g? You substitute g. G is delta s over t square. So what is this? 2s. So your g is, delta y over delta x, that is g. So when you, that is 2s over t square. So what is going to be y-axis? Delta y is 2s, delta x is t square. So your when you take 2s as your x-axis and y-axis and t squared as x-axis, so the gradient delta y by delta x gradient will give you the answer. So you get the answer by dividing 2s over t2. That is the gradient. So whenever they give to find y-axis and x-axis, you have to go for the formula with given data and find. Almost they are asking the gradient. Your answer almost equal to the gradient. You will understand when you do more papers, and we'll move. So now answer question number 4. Answer is B. This is the working. Now move on to question number 5. A student is investigating a material in the form of a wire. Which of the following properties of the wire will change if a longer wire is used? First one, material. They are talking about the material of a wire. Okay. So now, properties of the wire. A longer wire means they are talking about dimensions. You should understand the question first and their words. Now see, they want which of the following properties of the wire will change if a longer wire is used. Breaking stress. Now you think, this is not a property that will change if it is longer. I hope you understand, it is not a property, breaking stress. Density, this won't change either. Density is unique. So stiffness, I have a doubt. Keep that in your mind and go to D. I am always telling you to read all the answers. Young modulus, this will stay the same whether it is longer or shorter. You know that, young modulus. So answer, this will stays the same. So now they are asking, will change. Can it be D? No. So what is the answer? But you guess, it is stiffness. So if you don't know the answer, it is very easy to find. I'll tell you the way. If you don't know the answer, you take one by one, and you take now A, C, okay, it cannot be, and B, no. Then D also no. Then automatically you know the answer is C. Sometimes you don't know the meaning of C. You haven't heard the word. But even then, by getting rid of all what you don't want, will give you the correct answer. I hope you understand well. That is how you choose. Even if you don't know, you can catch the answer. Okay? They are giving hints for you to catch the answer. So don't be scared of what I don't know, I didn't get. You think and try to answer. So there will be only one answer. Okay? you go to number 6, question number 6. Two objects are traveling directly towards each other and then collide. Object A is a mass of 2 kg, initially traveling to the right at 3 meter per second, and object B is mass of 5 kg, initially traveling to the left at 2 meter per second. What is the total momentum of A and B after the collision? Now see, I will advise you in this. This is very easy question, collision. So you better write on the paper. You have to have. So now objects are directly towards, no? So I told you to mark direction. So these are before collision and after collision. So you write all the datas. It is 3 meter per second. To have a collision, the B should be in the opposite direction. It is 2 meter per second, and I have marked nicely for your reference, so you will understand in a very good way. Now see, 2 kilogram and here having 5 kg. So what is the equation? You know, that is momentum equals mv. So you write PA. This is the way you write. Then P of A, small a, down, and 6 kilogram meter per second. PB is 10 kilogram. You multiply 2 and 3. So you mark the direction. So this is bigger. PB is bigger. So after collision, it should go in this direction. From right to left, what is the magnitude? 10 minus 6. So what is the answer? It is to the left. Okay, answer A. Question number 6, answer A. Now we'll move on to question number 6. Very nice question. Now I will teach you how to think. A student determines the terminal velocity. Now he wants to determine terminal velocity. So you underline. Now you should know terminal velocity. So of a ball bearing as it falls through oil. What is the media? Oil. He releases the ball bearing at point V and measures the time taken for it to fall a measured distance. Which 2 points should he use for the measured distance? See, will you? Very nice question. That's what. It's mainly a thinking and a theory. Now see, now V to W. Can it be? It cannot be, no. Ball bearing it is falling through oil, no. But when you take the distance from V to W, actually V is in air, no. So medium is not similar. So V to W cannot be. Now go to W to X. Ball has just entered the oil. So you leave like that and go to next, X to Y. What do you think of X to Y? For me, of course, if I don't know even physics, I will say it is X to Y. Because it is suitable distance due to 2 reasons, longer distance and middle region. Everything is satisfied with X to Y. I'll talk about Y to Z. Why we are not taking Y to? Why it is? Are you taking Y to Z? No, this distance is less. Also, you get inaccuracy data because it is mostly under. So I am not going. Most relative answer is X to Y. I hope you are clear in this. So answer is C. Okay. Go to number 8. Which of the following is a vector quantity? You know, no? No need to. Density, you know, is scalar. Kinetic energy, scalar. Viscosity, scalar. So momentum is an answer. So I have written this. Anybody who doesn't know, so you can understand. I already write everything for you to understand well. Okay. Number 9. So now see, which of the following statement is not? They have highlighted. Not correct for a Newton's third law pair of forces. I'll advise you to learn all the laws, Newton's first law, Newton's second law, Newton's third law. It is in your textbooks. So any textbooks give you Newton's first, second and third laws. So I will advise you to study and see they are asking not correct for Newton's third law. So the forces act in opposite direction, that is third law now. So the forces acts on the same body, I have a doubt. So I'll keep that and I go to C. The forces are of the same type? Yes. The forces have the same? Yes. So Newton's third law says A, C, D. So it is not correct. It's B. That's how. Otherwise, I'm in a doubt of this. Don't know whether B is correct or not. So you guess and go and read and you will understand. Yes, all the others are Newton's third law and you will left with B. So you answer B. It's confirmed. Now go to number 10. A locomotive pulls a train at constant speed against a force of this. The output power of locomotive is 70. So some children, they are finding what is locomotive. I don't know locomotive. So they don't read the rest and try to understand. If you don't know the word, the meaning, leave that out. So you read the others. So these words are given for you to make sense. The question, so therefore, if you don't know the word, don't go deep in finding the meaning. You leave that out and you read the rest, you can answer. Remember that. So now locomotive pulls a train at constant speed. Against force is this. The output power is this. Which of the following gives a time in second for the locomotive to pull the train a distance of 1 kilometer? Now see, when you are reading, I told you at the beginning, if it is not SI, please turn into correct unit. On top of the paper, you write. It should be Newton, then I should multiply by 10 to the power 3. That's done now. So this is megawatt. So what is that? I have to multiply by 10 to the power 6 to make what? You do then and there. Then you will never make silly mistakes. Calculating. Which of the following gives the seconds to? So now 1 kilometer. We are not dealing with 1 kilometers. So we have to translate into meters. It is 1000. I have put in red for you to understand. Now see, they are asking P. So P, you know, it is F and V. So what is V? Distance over time. So when you substitute V, D over T, P is going to be FD over T. You know P. Okay? You know the power. So this question is based on power. So you go to power lesson and you should know the equation for you to start with. So you start with that. So you don't give the proper start. You don't automatically you are getting the answer. Maybe you don't have any clue, but even then you give the proper answer. They are talking about power. Okay, I know power, force and velocity. So you continue with that. Give the proper start always. So you apply this for power and for F, you know the 8400, that is Newton, and D is given, na? So T is this. So what is the answer? 8.4 10 to the power 6 into 10 to the power 3. What is the answer? Answer is C. Okay, very easy. So don't think your physics paper is hard. You have to give the proper start and then it's very nice for you to answer. You have to practice, okay? I'll give all the information, necessary information for you to think. If you get 10 out of 10, Almost very good. Okay, so try it. They are very easy. Only thing is thinking ability. So I'll improve your thinking. Okay, now go to section B. Answer all questions in the spaces provided. A uniform plank of length 4 is pivoted 0.9 N from 1 end. Weight of the plank is 250 Newton. A person of weight 950 and stands at one end of the plank. A person of weight 650 and stands distance x from the pivot so that the plank is in equilibrium as shown. Okay, so now I have drawn everything, reaction force acting on the pivot. So this is what you should know. Okay, so now see, if 9 very easy to mark now all. So see, I have marked 950 and 250 and 650 everything there, and length they have given 4. I have marked 2. Add to the diagram to show the forces acting on the plank. Okay, now calculate the distance. Now see, you know, sum of the clockwise moment equals sum of the anti-clockwise moment. Considering moment from the pivot, why we take the these equations, you have to mark the direction. Why we take the pivot now? Here, when you have the pivot, actually there's a reacting force upwards to the plank from the pivot. But we don't know that. To ignore that, we take O point. So you don't need to bother, because if I say it is R, reacting force of R acting O, distance is 0 to the pivot. So that means R is going to cancel. So if you want to cancel any force, you have to take that point. Okay, so if you don't want any force and you want, because sometimes they give unknown 2 forces, so you have to cancel one anyway to find the other. So take that point as the as for calculation. So that force is going to be cancelled. I hope you understand. Okay, so calculate the distance. Now I am taking O. I want to cancel the reaction force acting on this, because I don't know R. I don't know that. So I am taking this way. So this way, come along the plank. Always from the pivot, come along the plank and turn. It is going this way, clockwise. Therefore, it is plus 650 into x. Now go to next. That is also you come along the plank and turn. Okay. So then I am always telling come along the plank and turn. It is forward. It is directed down. That means again that is plus. And you come another only one force. Come along the plank and turn. It is the opposite way. You put minus 950 from the distance from the 0 to plank. It is 0. No, sorry, it's 0.9 known. So everything is now, it is in equilibrium. So you have to write, because it is in equilibrium, it is equal to 0. Okay, so you have to write here. I haven't written, so you write in equilibrium. This is going to, the word in equilibrium should come there. So now you find this, x is this. So you are putting the answer, you are getting the answer. Now see, I want to talk about something about your answer and what you get. Now go to the question, distance. Distance is given in 2 decimals. So your answer should have 2 decimals. Then work for extra 1 decimal and round it off to 2 decimals. Remember that. So what you get is not your answer. I have to work out for 3 decimals because I have to give for 2 decimals. Why? They have given distance in 2 decimals. Therefore, please, you have to remember your answer is getting 1 mark. So your calculated answer is not the answer you write here in answer cage. You have to convert to correct decimals as they question. Okay, I hope you understand what I am telling. Now question number 12. So now see, when you see the diagram you will get scared. I am telling you, don't get scared. You just read. It is one of the theory you have already know. So now see, moving walkways are often found in airports. So they are giving the statement and everything. So why are you bothered about the picture? One moving walkway carries passengers up an incline of 30 degrees as shown. So since they have given the correct picture and also they have given the diagram also. They have given the diagram also. Okay. Sorry. They have given the diagram. Okay. Now see, you mark everything. You mark U is 0.51 m. The man is here and it is at angle of 30. I will tell you how I got this 30. If the angle given is 30, when you draw this it is 90. So this angle is going to be 90 minus 30, 60. And also this is 90. Therefore this is going to be 30. So you know the 30 and I have given you projecting. Now see, this one is going to be, this is a working for you to know how I get 30 and mg is directly down. And when you turn, when you resolve vector into with angle, it is, if you are going through the angle, it is always cos. So mg I want to resolve in this direction. So I am going through the angle 30. Therefore I write mg cos 30. Okay. The other way, mg sin 30. So here alpha is 30. Remember again, if you are resolving one vector with an angle, if you are going through that angle, it is going to be cos. If it is no angle here, it is actually 60, but I have not mentioned. You are giving with 30, it is sin 30. Okay, so this is how you resolve this mg, because we are taking like this inclined planes moving, so we are using along the plane and vertically to the plane. Therefore, I need to resolve 72g. A single passenger of 72 stands. The speed of walkway, this 0.51. Show that the rate at which the walkway does work on the passenger is about. So show that. Very famous question. They are giving you the answer. Rate means always you have to divide by time. So does work. Rate means you have to divide by time. Now see, you have to get 200 watt. So now see, how are you going to take? Projecting power. You know, no. Rate of work done, they are asking. What is rate of work done formula? Work done over time. I told you, no, rate is, you have to divide by time. What is work done? WD over T. It is P. So power is force along the plane and velocity. So you know this equation. So 72 sin 30, because that is the force along the plane. And that U is this. So you are getting 180.1 W. So that means 180. So always, so you have to show it is 200 watt. 200. So passenger 200W. So 180W is almost same to 200W, because now they have given work done in round, they have rounded off to 3 significant. So when you round it off to 3 significant, it is 200. So therefore it is power is going to be 180W. Okay, the walkway, question number B, the walkway system has an efficiency of 70. Anything, any machine, you have efficiency. You cannot get anything 100% efficiency. So your answer should be less than 100%. Anyway, efficiency. So when you calculate the power input system, when 15 passengers of average 72 standing. So efficiency, you know, useful power divided by power input. I hope you know this equation. So it is 178% means you have to put 0.78, 180 now 100. Don't put 200 now. Here that is the approximate about. Can you see about? About means they have rounded off. You have to round it. It is not exactly. So this word you have to know. That's what you are telling. 180 is almost 200W. Show that. Okay, but when your calculation, you have to take your original value. You cannot take 200. It is about value. It is an estimation. So now you put 180 into 15 power input. You divide. Then you are getting 34,61238W. So that is, you have to give for, you have to round it off. Okay, so that is 3,500. Okay, power input. Hope you understand. Okay.